Magnetism versus gravity. Gravity versus magnetism. What is the difference? How do they work together? And how does all of this fit in? I mean, I've struggled with understanding exactly how gravity works. It's, to me, somewhat baffling when you apply the same principles to other objects. It doesn't seem to work. But hey, maybe by the end of this program, we might have a better understanding. Let's see. So we look at this from a viewpoint of what is gravity and what is magnetism. So gravity works where mass is the source of gravity, whereas magnetism is moving charged particles and magnetic materials are the source. So mass is the source of gravity, moving charged particles and magnetic materials are the source for magnetism. All right, so let's look over here in gravity. Always an attractive interaction, whereas magnetism, like poles, repel, but opposite poles attract. Gravitational interaction is very weak, whereas with magnetism, it's very strong. Graviton is the mediating particle responsible for the interaction, okay? Where the photon is the mediating particle responsible for the interaction. Okay, there are no poles in gravity. South and north poles are markers for magnetism. All right, that makes it a little bit easier because now we can define better what is these two forces. So we all know and experience what gravity is. Now, the interesting thing about gravity is that it's equal at all points on the globe. And it's important because gravity can only work in a globe, a sphere. It's the only way it can work. Whereas with magnetism, you have, again, repelling forces. We have on our planet a magnetic North Pole, and we have a magnetic South Pole. And we have a geographical North, and we have a geographical South. And in between those two, we have the rotation of our sphere. So what is the difference between a magnetic force and a gravitational force? Well, in this one here, I tried to show out how these two forces work in conjunction and with each other. Gravity acts on all matter, always pulls. Its strong and weak nuclear forces hold the nucleus together, whereas magnetism acts on charged particles and pulls or pushes. That should begin to help a little bit, right? Gravity and magnetism are not the same thing. In fact, they are completely separate forces. So we know this because if they were in fact the same type of force, you would basically have a natural pulling. Whereas we know in magnetism, it's a pushing away. And we know as well is that within our Earth is that magnetic north and geographical north are two different things completely. You can have a geographical north and actually have a polar flip where you would actually have a magnetic north at the opposite of your geographic north. So no matter where you are on this planet, there is an equal pull no matter where you are. That's the force of gravity. Gravity is a force that acts between any two objects with mass, no matter what they are made of. Both objects get pulled towards each other just because they have mass. The reason it seems like gravity only pulls you towards the Earth is because the Earth is so big that the pull from you on it isn't enough to do much to the Earth's motion. The planet is just so large. A lot of people don't think about that. And thus, you, myself, a 30-story skyscraper would not have that much of an effect on the Earth. Okay? So always equal in force at all points. That's the amazing thing about gravity. It has no sense of center. It's just on all sides equally, the pull. Gravity, however, diminishes with distance. We know that. We can see that by our artificial satellite called the moon. We can see the play that our planet are with the sun. The same thing with the other planets. Now, because of mass, we know that the Earth has a greater gravitational field force than, say, the moon. But the sun has an even greater gravitational force than the Earth. So that has a direct correlating effect as we continue to go further with this. So we can understand now why a person, say, in South Africa to a person in Alaska would have the direct same force pulling on them no matter where they are geographically. So which would fall faster, a pound of feathers or a pound of lead? Well, when you understand gravity waves versus gravitational waves, this gets really interesting. All right, gravity waves are mechanical waves. Gravitational waves are not mechanical waves. Gravity waves are fluid dynamics, can be used to explain gravity waves. So fluid dynamics, and we're going to see some of this, because otherwise gravity doesn't make much sense, but we'll continue. All right, so on the gravity waves, the speed of gravity varies. Gravity waves transfer energy through matter. Detection of gravity waves is very important in weather forecasting and disaster management. Gravity waves need a medium for propagation as they are mechanical waves. Gravity waves are attenuated significantly by physical barriers. Now, you look over here on the gravitational waves, which are not mechanical waves. The theory of general relativity predicts the existence and formation of gravity waves. Gravitational waves travel with the speed of light. Gravitational waves carry energy away through empty space or matter. Gravitational waves are supposed to carry very important cosmological information. Gravitational waves don't need a medium for propagation, and the attenuation of gravitational waves when they pass through physical barriers is negligible. That is important. Unlike gravity, which occurs between any objects, magnetism depends on specific properties of objects. Magnetism can either pull the two objects together or push them apart, depending on which way the magnets point. most importantly, it depends on what is going on with the electrons in the material, since each electron is like a tiny magnet itself. So when you begin to look at the rotational axis, that you have the magnetic field lines, and then how it sets up through the geographical pole, you can begin to see, in theory, this is how gravity works. Now, for a layman, I'm seeing that you can't have gravity without having magnetism, and vice versa. I could be wrong on that. So particles change from positive to negative. We know that. We can measure it. We can actually see it. We have it here in the aurora borealis. All right, so both magnetism and gravity can affect objects at a distance. Both get weaker as the objects get further apart. This is why you are affected by the pull of gravity from the Earth, but not from distant planets. Think about this. Mars doesn't have an effect on us. The sun doesn't have a pull on us. It's also why two magnets may move together if you set them near each other, but if you set them far apart, nothing will happen. However, as two objects get far apart, the gravity between them goes down by a factor of 4 when you double the distance. But the magnetic force goes down by at least a factor of 16. On the scale of the solar system, with planets far apart, gravity is much more important than magnetism. Or is it? Let me ask the question. When you begin to look at the interaction of gravity on a mass and then apply magnetic fields to that, you have the most amazing interaction. So magnetism versus gravity, right? Magnetism and gravity are not similar concepts. These two concepts or terms are totally different from one another. Although both are considered forces, they are two different forces with different properties and different characteristics. This begins to help explain why we have a magnetic north and a geographical north, and why there is a deviation in the tilt, the spin of the Earth. First of all, gravity as a distant force acts on two objects no matter what their compositions are. You can have, for instance, a gas giant. You could have a water planet. Gravity is still going to be at play. As long as the objects have mass, gravitational forces will act between them. Any two objects, as long as they have mass, will be pulled towards each other if there is gravity or gravitational force. Now, this is according to New Cambridge School. Consider an example of a balanced force, a person standing upon the ground. There are two forces acting upon the person. The force of gravity exerts a downward force. The force of the floor exerts an upward force. Since these two forces are of equal magnitude and in opposite directions, they balance each other. The person is at what we call equilibrium. How many of you know, if you've ever had an ear infection, you get your equilibrium out of sync in the inner ear, you know what happens. There is no unbalanced force acting upon the person, and thus the person maintains in a state of motion. That's why we don't spin off into space. In contrast, magnetism primarily depends on the specific properties of the object. The force of magnetism has two directions. It can pull objects together, or it can also pull them away from each other. The behavior of magnetism is also influenced by the alignment of electrons inside the object. This is not the case with gravity and gravitational forces. Gravity is a force that we feel everywhere in the world that comes from the Earth itself. Gravity is important because without gravity, we wouldn't have day or night. So the forces at play here become even more dynamic because now we see the forces of both gravity and magnetism. And actually, it's electromagnetism because, again, we deal with the fact of the electrons. And this is how the law of gravity is showing that the net gravitational force on a mass, m, anywhere inside a uniform spherical shell of a mass, m, is zero. The gravitational effect of the ring shown will be the force to the right, but a compensating force to the left will be exerted by a smaller ring on the left, which is closer to the mass. And this is where we begin to get dynamics interacting. With gravity, all objects with mass are sensitive to its force. With magnetism, only few objects are sensitive to its force. In fact, the majority of objects on Earth are insensitive to magnetism, while all objects on Earth are affected by gravity. To visualize this phenomenon, if an object is not sensitive to gravitational forces, then it will be ejected from the Earth all the way to outer space. Gravity is unique to heavenly bodies. Stars, planets, and satellites have different levels of gravitational forces. Meanwhile, magnetism is naturally occurring to some ferrous yes, objects or materials, and only few magnetic materials are ferrous objects. There is a big difference between magnetism and gravity. You should not make the mistake these concepts as one and the same. Gravity affects all objects no matter what their composition and properties are. Even plastics and wood can be affected by the force of gravity. On the other hand, magnetism only affects specific objects. Some objects are insensitive to magnetism, while others are highly sensitive to the force of magnetism. So you have the inertia, what we would call the inertia mass versus the rest mass. So inertial mass is the mass of a body as determined by the second law of motion from the acceleration of the body when it is subjected to a force that is not due to gravity. Increases with the relative velocity of the particle with respect to the observer, equivalent to gravitational mass and energy, and it's additive. Now, versus when we look at rest mass. Rest mass is the mass of a body as measured when the body is at rest relative to an observer. Okay? So doesn't change with the velocity of the particle with respect to the observer. Rest mass, not equivalent to either gravitational mass or energy, and it's not additive. So this is why we have the problem with gravity if it was a uniform force. Because in this example here, we can see that depending on the mass, the density, how gravity works. It's quite fascinating because you can see that each one of a solid mass object will continue to fall through the force of gravity. But if you begin to look at the layers, in this case of liquid, you can see clearly gravity has a different reaction to the density. Tell me again while I'm trying to disprove something that has never been proven. All of this that I'm talking about is theory, and it doesn't add up. So when we look at the atom, right? We have a proton, which is positive. The electron is negative. This is a hydrogen atom. So the return to the classical model proposed that all subatomic particles are resonant systems of near massless charge subunits, positive and negative, and the electron has structure. Okay. Newton's first law applied to falling objects. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Before release, the object in state of rest, airspeed 0, weight, but no drag. When object is released, object accelerates, airspeed increases. Drag depends on airspeed, which then drag increases. When drag is equal to weight, object no longer accelerates but holds at constant velocity, what we call terminal velocity. And that's how they measure all this. Is this how Newton conceived his theory of universal gravitation? The legend of a falling apple providing sudden inspiration to Newton has little credibility. It is a nice story. However, Newton's conclusions were this: force equals what we would call G, m to the first times m to the second, over divided by d to the second. All right, so m1, m2 are the two masses, d is the distance between them, and g is the gravitation constant. That's how it happened. Never happened with any, how shall we say, inspiration of an apple. So we look at how this all works. So we have the classical mechanics, we have the Newtonian gravity. Classical mechanics leads to quantum mechanics, which then leads to special relativity, whereas with the Newtonian gravity, we go to general relativity directly. And then somehow or another, this gets us to quantum gravity. But what apparently even Newton did not factor in was electromagnetism. Because even within the gravitational forces, we're still impacted by magnetism. So this then has led to, from what we have was the standard theory, to the theory of everything. The theory of everything kind of basically condenses this mess that we have with the standard theory, the Newtonian gravity, modification to the Newtonian gravity, general relativity, atomic magnetism, special relativity, weak nuclear force, subatomic magnetism, are you getting it? Where the theory of everything says, okay, we got a single principle. Within that single principle, we have specific structure. And within each one of these substructures, we can then begin to account for the peculiarities that we find within the standard model. So when you have, for instance, what is gravity? A small force of attraction exists between two objects. The force gets weaker with increased separation. The force gets larger as the objects get larger. So when you begin to look at the charged planets, gravitational induces dipoles tend to separate charge. Planets act like they're electric. Free electrons tend to drift towards the surface. Like a particle accelerator, the electrical stress modifies the apparent mass of the planet. Removing electrons from the surface through lightning reduces the mass of the planet. Maybe that's how rocks disappear. So we know how magnetism works on our bodies. Our bodies are subjected to two distinct forces, each having its unique effect on us. It even affects our blood. So, with so many different variables within gravity, is it an illusion? Well, there are some theoretical physicists who say yes, because there is no uniformity. If gravity is not strong enough to stop a small stream from flowing to its lowest point, then what is stopping the oceans north of the equator from emptying into oceans south of the equator? This is what the Earth would look like if we lived on a globe. Gravity is a pseudoscience, a theory that cannot be proven. You explain that. So we get into this thing called electric gravity. Now, this one is a theory where every particle within each atom is made of orbiting mass charges. Every subatomic particle is distorted by the presence of others to form a tiny electric dipole. Like magnets that are free to rotate, all the electric dipoles in protons, neutrons, and electrons line up to produce gravity. Neutral atoms, distorted by gravity, induce an electric field inside a body. Electric gravity. And you can see how this works. The strong forces bind the nucleus. The weak force in radioactive decay leads to electromagnetic forces that bind the atoms. Gravitational force binds the solar system. Now, electromagnetic forces between two atoms now begin to have the effect of both attraction and repulsion, which some theorize aids in gravitational forces. So gravity is a pulling force. The Earth pulls an object with the force of gravity. The objects are pulled down towards the center of the Earth. The moon and other objects have gravity too. In fact, everything pulls on everything else because of gravity. But we only notice this pull when something is huge, like a planet or moon. Magnetic forces. Magnets attract and pull on some kinds of metal. A magnet can attract or repel, push against another magnet. These forces are magnetic forces. Magnets have two poles, north and south, as we have discussed. The north pole of one magnet attracts the south pole. That's the whole problem with the water situation. It seems like we got a contradiction here. Well, if you look at the electrostatic forces is the force that acts when an object becomes charged. Most of the time, objects become charged when they rub against each other. Electrostatic force can make an object attract or repel to each other. This is a diagram of such an approach. Now you begin to think about applying this now to other theories. It begins to change everything. It would also begin to explain why we would have anomalies within the Earth's core, the structure of the planet, within its gravitational forces to its electromagnetic forces. And this is how it will actually works. You can see exactly what Dr. Albers was talking about here. Now, this would then begin to equalize the forces at the center, which would, by the gravity force alone, would begin to have problems. And then when we begin to apply the magnetic forces, this is where things get a little odd, because what we see on our planet is not necessarily the same that we see in other planets. This case is Neptune. Neptune is one that we have seen continually flip. You can catch Neptune when it has virtually the same rotational pattern as Earth. Then you can see Neptune turned on its side. It is suggested that within Neptune, there are some very interesting dynamic forces at play, very strong electromagnetic forces at play, reminiscent of a star. Whereas with the Earth, if we had the same properties that Neptune has, it would not be able to sustain life. It would be, well, a topsy-turvy world. So the difference between an electromagnet and a permanent magnet. Now, if these properties exist that we can induce here on this Earth, then the same properties should be able to be induced in other environments, as long as you have the conditions set for each one. Just as well as you can have a difference between a bar magnet and electromagnet. Again, it's induced by the electrons. Now, gravity can only exist if there is a sphere. It's the only way it can work. Everything in the universe can be divided up into between forces and particles. Forces are gravity, magnetism, strong nuclear forces, weak nuclear forces. Particles are matter and antimatter. Now, hypothesis is a method of logical reasoning employed when given a limited set of possibilities in order to arrive at knowledge by way of the exclusion of known negatives, describing what something is by explaining what it is not. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Arthur C. Doyle. Now, this is why we don't need petrochemicals to run our machines. There is inductive currents naturally occurring within our planet that can be harvested and controlled to generate power. In fact, we had an individual that began to set this motion of the theory of everything, that everything is directly connected through an electromagnetic force. And as you can see in this diagram, how it affects everything that we would call and connect it to life. When you talk about your chakras, again, all depends on the electromagnetic fields of this planet. It has an impact on our brain. We know that. We're now doing experiments and mastering it, how we can alter the brain, again, by electromagnetic fields. And we're getting much better at this now. We're now understanding the concept of free energy. There was another who knew this nearly a century ago, a gentleman by the name of Tesla. He figured it out. And now we're figuring it out. Now, eventually, the powers to be will have to admit we don't need to be burning fossil fuels. We don't need to be charging anyone for electricity. We don't need to be burning anything. The earth would supply an unlimited, unbountiful, I don't think I said that right, unlimited again, amount of electricity. In fact, you can harness this so much that you can actually develop flying craft. And in fact, that is exactly how it works. When you begin to see that this has been basically suppressed, but always right there in front of us. Again, the electromagnetic motor has existed for over 100 years. There is no need for ever a brownout, no need for ever a lack of electricity, no need even in the case of a disturbance from our sun or another object where you could not immediately pick up, even in reversed magnetic fields. Because no matter how the balance is, we would benefit from it. Wind turbines don't need wind to function. All you need are magnets. It's how the UFOs work. We understand that. We understand the dynamics now of inducing electromagnetic fields. We understand this as it works with quantum mechanics, special relativity, Newtonian mechanics, general relativity, quantum field theories. We now understand how the artificial rotation of an elliptical device induced into a field separates the electrons and begins to generate its own separate sphere. The negative mind. God is consciousness, not a creator. God is the source of creation itself. It, not he or she, it is not independent of you. It is the totality of everything. So when I call myself God, I am not talking about my personal self. I am talking about the expression of the God self that rests inside of me. The verb, the energy, not the noun. Once you think God is a noun, person, place, or thing, you separate yourself from it and immediately become a limited being. That's what separates the believers, the religious, from the knowers, the spiritual. Let me out. How many of us feel like this, right? It is weird, is it not? I mean, folks, we live in a very, very strange reality.